Hello, my name is Cristian Alejandro Gamperez, and in this video I'm going to cover some of the topics of the requirement gathering process. The requirement gathering process is a process of identifying and documenting the project's exact requirements from start to finish. Uh, this is for the subject of software analysis. As a little introduction, it's important to say that gathering software requirements and writing use cases are some of the first steps that every software development process must undertake. And when deciding to develop a software application, one of the most critical components is the software requirement specification, or SRS. This is a document or set of the documentation most of the time that describes the features and behavior of a system or a software application. Um, well, two key components of the SRS are the actors and the use case, and that will be the topic of this video mainly. First we have the actors. Actors are those individuals or systems that will interact with the application, and the use cases are a series of steps or related interactions that are performed by actors on the system to complete a goal. Well, first we have the actors. What is an actor? An actor specifies a role played by a user or any other system that interacts with the subject. Well, the thing about actors is that when people think about defining actors, they think it's an easy task. They only say, who will use the system every day? And they only think in their own perspective of who do I interact with through the system. For example, in a bank system, people will only say, who are the actors in this case? They think about the customers and the bank. And that is not true because we can have many other actors that interact with all the system. And there are several others who interact with the system. It can be from a software perspective, but also from other external software and hardware too. Actors can be people, other systems, time triggers, or event triggers. Here we have a little image where we can see some actors. Well, first we have the one that most people know, the users. We can also have database systems that they storage information. We can have client and servers that serve the web page that we usually use every day. Cloud platforms nowadays can also be actors, and sensors that most of the time work as triggers for some applications. And the characteristic of actors, well, first, actors are always outside the system. They are not in the system and they only interact with the system initiating a use case. And the thing is that the interaction with the system can change depending on the use case. So a single individual can represent different actors, and an actor can have different use cases in their perspective. Categories of actors. Well, the actors are categorized in two different categories. First, we have the primary actors, and the most important. The primary actors are the actors that are directly interacting with the system to achieve a user goal. For example, we have the administrator. What does an administrator do? Well, they assign roles in the system, create account permissions, update the software. We can also have the project manager that schedule projects, define requirements, check the project status, generate reports on the advance of the project. We can also have the customer. The customer or the user usually search products, purchase products, create a wish list in their account, or check their profile. We also have the secondary actors, also known as supporting actors. Here, these are the actors that are called upon to complete a goal by providing a service. For example, we can have the web API. Web API or application programming interface extends the functionality of a web browser or a web server, so practically it's providing that service. We can also have a database server that provides or stores data in a relational or non-relational format. And in a more simple way, we can also have a printer. A printer will practically does one activity. For example, if an administrator or a project manager needs to print something, they can use a printer, so that will act as a secondary actor. Here we have an example of a primary and secondary actor simultaneously. A user clicks the search button on an application's user interface. The application sends an SQL query to a database system. The database system responds with the result set. The application formats and displays the result set of the user to the user. Well, in this scenario, the user is the primary actor because he initiates the interaction with the system, in this case the application, and the database system is the secondary actor because the application initiates the interaction by sending an SQL query and the database responds to that action. We also have another way for classifying the actors. The reason of this is because analysts usually miss key actors during the use case diagramming process because they only identify the human actors. For this reason, we have this classification. Here we have humans, system software, hardware, and timer clock. In humans, for example, we can have a customer that wants to purchase products and a student that wants to know his grades, a player if it's a game. We also have system software, for example, an integrated development environment or IDE that developers use to make the code, a database software for managing the information in the website. Hardware we can have the server where all the information is stored, or a monitor to show information to the user. Timer clock, for example, we can have a timer session or a periodic signal. Categorizing the use case actors in this way helps the analyst ensure they haven't overlooked any critical actors within the use case diagram, so it's pretty beneficial. Another important aspect of actors is the generalization of actors. Well, generalizing actors means that one actor can inherit the role of another actor. Oh, this is useful because when we are trying to organize the actors, we usually identify the most general actors and then we think about the more specialized roles. For example, we can have like a customer and then we have two descendant actors, new customer and old customer, and both these actors will share the use cases of the normal customer actor, but they will have more specific roles, so that's practically the reason that we can generalize actors. And actor generalization is useful for describing role-based permissions, because some roles are the extensions of others. Is a more useful way to have a better understanding of the process. Actors in software design. Well, this is the main topic we are going to cover. The requirement gathering process involves people who are primarily interested in the problem to be solved, and as well as people interested in the solution. So here are the actors that mostly interact in the software design part. First we have the user or system and the end user that is sometimes called, that they are responsible for using the system after it has been finished and delivered. So they are a very important part because they are the main people that are going to use the software, so most of the time they will cover most of the use cases. We also have the developers that they are responsible for developing the software project. Most of the time this group is composed by software engineers, but it can be any person that knows how to develop the code. We also have UX and UI designers. They are responsible for transforming a product vision into the user-friendly designs we use in our applications. They create user journeys and focus on the best user experience, so people, when they use our system, they have the most comfortable way of using it. Another actors are for example, the customers. They are very important because they are responsible for commissioning the software or paying for the software. So they are well one of the most principal ways that we develop, and they also sometimes represent the software target market because sometimes we are developing a software with and we don't have a primary buyer, so they can also work as a software target market. We also have the product owner that they hold responsibility for the product vision and evolution, and most of the time they make sure the final product meets the customer requirements. So they are pretty attached to the customers and they kind of have a relation between them and with the software team. Another very important actor is the project manager because he is responsible for planning, scheduling, budgeting, estimating all of the tasks in the software project. Most of the time, people don't think about all the little details that they miss. So the project manager is responsible for almost all of that. So they have a very important role in the development of product, and they also try to motivate the software development team to make a better product and work in a more friendly environment. We also have more specialized actors. These actors not always will interact with the product, but sometimes they can be very helpful. First, we have the market analyst. Uh, in case of a mass market software product, sometimes there won't be a direct customer, so this actor is responsible for establishing what the market needs, and sometimes they act as a proxy customer, so kind of a different type of customer that will represent what the product is for. We also have regulators. Some cases like in banking and public transport, these application domains are regulated by the government or other laws. So the developed software must comply with these authorities. So the work of the regulator is working on that part, try to make all the software comply to the regulations in the government laws and requirements. And lastly, we have the domain expert. Sometimes when we are working in a very specific task, we also need the help of very skillful people in the domains. So the domain experts are responsible for providing information about the application domain and the specific problems of that domain. So they have a better understanding of the task at hand. So they are very helpful when we are working in more specialized topics and research teams. So they are a great help. And that will be all the actors. Next, we have the second important topic we are going to cover, and that is use cases. A use case is a text document which describes a scenario in which an actor interacts with the system. This use case integrates the requirements in a comprehensive package, so the interaction between the user and the system is what is most important. The use case should describe this interaction very truthfully. What the actor does first and then how the system reacts. That is the most important part a use case should cover. Um, you need to be careful to when you are making a use case because it only needs to describe how the system reacts. It's not important to worry about the implementation of the system or how the interface will be. It only needs to tell how the system will react. And of course, an application will be described by many use cases, and the exact number of use cases will depend on the size and complexity of the system. And each use case should provide some observable and valuable result for the application, and the actors and the stakeholders of the system. Now I will show you an example of a use case diagram. Using diagrams is the most common way that software development teams work their use cases in their projects. I decided to do a library management system, so I will show a little example of how we can make the use cases using this method. Here we have the example of a library management system. This system is developed in the Unified Modeling Language that is a general purpose developmental language that is very used in the software engineering, and it provides a way to design a standard way to visualize the design of a system. The system is represented in this rectangle and with the name of the system at the top. We also have actors that are these stick figures. Um, is someone or something that uses the system to achieve a goal. We also have the use cases that are represented in these oval figures. They are use cases, and the actors interact with the use cases. We can have actors both in the left side and the right side. The difference is that the left side is for primary actors and the right side is for secondary actors. And we also have these relationships, these straight lines. It's a association, and we also have these pointed lines that they have another meaning. They can be include associations or extend association. So I will explain this diagram now. Uh, in this case, it's a library system. We have the actor as an user. We can generalize the actors. We can make more actors that are more specialized. In this case, we have a user can be a student or a school staff, and these actors can have more or less use cases than the base case. So what are the use cases in this system? Well, for the user, first we have to create a new account. As I said before, we have a relationship of include that says field registration form, and include relationship means that every time the first use case is done, and the second use case will also be done. So it's an include relationship. When one thing happens, the other will happen always. As I said, we have also borrow a book. That could be another use case that a library system will have. We can also return a book, renew a book, and in the case also is reserve a book. So the main difference is that in the case of renewing a book, we also have an extend relationship. And the extend relationship means that it not will always display this use case. In some cases, when certain criteria are met, these use cases will be displayed. In this case, display a renewal error, book already reserved. For example, if we are trying to take a new book and most people have already take it, so that would be an extended relationship. And all these cases, in the case of borrow, renew, and reserve a book, they all share the same include use case, so they can all be connected to the same one. And also in some of these use cases, the library database will act as a secondary actor because, for example, when borrowing a book, we need to check the library database to see if the book is available, or when renewing a book, also we need to check if the book is available or if the book is not reserved. And when reserving a book, we need to change the database to tell the database that the book is now reserved. We also have more actors. We have, for example, the librarian. That will be the person that works most of the time with the management system, and she will have more privilege than a user. For example, he or she will have the ability to add a new book or record, update a book record, or delete a book record. So these are all use cases that also and other actors can have, so the management system can keep growing in case we have more actors and more use cases that we want to add to the system. And they all share the same include relationship of searching and updating the database, and everyone is connected to the library database because that will be the main secondary actor. We also can share between these actors some use cases. In this case, search for a book in the database is an action that both the user and the librarian can do in the system. So that would be a way of displaying the use cases that is most used nowadays because it's easier to understand and it shows a very graphical way of displaying relationship, and that will be this example. Here are the references I used in the making of this video.